Okay, so we are solving the next question. Okay, so this is the question. You can read it. So this question states that initially a grasshopper is present at a coordinate x number. From there, if he performs a series of jumps. Okay, in each jump, if he is present at an even coordinate, the next jump will be towards the left. And if he is at currently an odd coordinate, he will jump towards the right. And the distance of each jump will be exactly the minute or the time he makes the jump. So for the first minute, the distance he jumps is 1 unit. For the second minute, he will jump a distance of 2 units. Okay. So what we need to do is just let's have some fun with the problem. Okay, we'll just simulate how we can see. Let's assume the first approach I tried was a brute force because as the everything is given in the question, so we can directly do the manual way that check at the present coordinate if it is even and then change the position. But let's see, let me show you. See, this was my approach earlier that for each jump, if is at present at an even coordinate, then change the coordinate like it is jumping towards the left, and if it is at odd, then do the necessary. This was the minor brute force way. But as you can notice, I have got a TAE because the number of jumps is very much greater than the time there. 1 second is nearly 10 to the power 8 operation. So for each test case, we have 10 to the power 8 operations. But according to my solution, it was exceeding that. Okay? So the manual way wasn't working. So we need to find a new optimized way, some mathematical observation or anything like that. So let's do it. So let's assume we just have another problem and start simulating from the easiest case. We'll build up from that. So initially, let's assume the grasshopper is at x equals to 0. So as it is considered as even, he'll move towards the left and find distance 1, and this is the first minute. So he moves towards 1. Okay. Then as it is odd, he'll move towards right by a distance of 2, right? And this is the second jump, so distance will be 2. Now again, this is odd, so he'll move towards the right, and the distance will be of 3 units because this is the third jump. Now again 4 is even, so we'll move towards left by a distance of 4. So we'll go back to 0. Okay. So what we did was we simulated the first 4 jumps from 0. Okay, let's go for that. I don't think I have anything noticeable. So let's move ahead. Okay, the next jump will be so the jump will have 5 distance units. Okay, so towards the left as 0 is even. Okay. From here, then minus 5 is odd, so it will move towards right by distance of 6. Okay, then again, from here, it will be odd, so towards the right by a distance of this will be the seventh jump, right? So he'll go towards 8. From 1, he'll go to 8. And from 8 back to 0, right? He'll come back to 0. So this is the simulation of first n steps. Let's Okay, you might have noticed something. Okay, here that he is again and again retracting back to 0 after 4 steps. You can notice that. Okay, that one, two, three, and the fourth step. After 4 steps, he is repeating the pattern. So let me show you. Okay, so this was the first 4 cycle, right? Jumps here, decrease a bit. So he jumps here, 2, 3, and 4. This was the series of first 4 jumps. Now he comes to 0 and starts from there. Plus this time the distance will be more because it will be the fourth of the next jumps, right? So next jumps will be, we'll mark it with a different color. So this, this, this. and again back to 0. So as you can see, after every 4 jump, this is the pattern. You can observe it, right? So this is a pattern. What is happening is, with as we go on increasing the number of steps, the distance keeps on increasing. As we earlier, it was just a small pattern, but now next 4 has a bigger pattern. The next jumps will have even bigger pattern, but the pattern is same, right? So after each jump, we can assume which position it will occupy. How? Let's say, because after each 4 jumps, he comes back to 0. We know that it is repeating, the pattern is repeating every 4 jumps. So we'll have a manual note down right here. So if we start from 0 and we simulate it, if there were n jumps, okay, these are the number of jumps. These are the number of jumps. And this is the final position he is at after the n jumps. So if there was 1 jump, he'll be at -1. 2 jumps, 1. 3 jumps, 4, 4. 4 jumps, 0. Then again 5 jumps, -5. 6 jumps, 1. 7 jumps, 8. 8 jumps, 0. So each number of jumps, if it is a multiple of 4, then the final position is always comes to 0. This is the observation we have to do. And similarly for these other numbers also, if the number of jumps mod 4 is equal to 3, then the answer becomes the number of jumps plus 1. So for 3 it is 4, for 7 it is 8, then next for 11 it will be 12, for 15 it will be 16. Got it? And for each mod equals to matlab, number of jumps minus, sorry, number of jumps mod 4 equal to 1, it will be -1, minus of that number. So 1 will have -1, 5 will have -5, 9 will have -9 as final position, and then 13 will have -13. So it is a pattern that for each modulus, let's say k equals to the number of jumps mod 4. So if k equals to 1, then the answer will be minus of n. If it is equal to 2, it will be 1. Yeah, see, 2 has 6, 2 has 1, the 6 has also 1. And if it is equal to 3, then the answer will be n plus 1. And if it is equals to 0, that is, it is a multiple of 4, then the final position will also be 0. So this is the observation we had to do, that for each point it is a pattern of 4 segments, right? So each jump is like, he'll jump to left, then right, then right, then left. Left, right, right, left. Left, right, right, left. Okay. So that was the observation, that it is a pattern. Now we'll get into the nitty-gritties. So let's assume, what does this pattern depend on? Okay. So this pattern starts from 0 and it moves towards left from the beginning. Why? Because the 0th element is considered as even. I have color marked it. All the even elements are blue and all the odd elements are green. So it depends that if the initial position is even, then he'll move towards the left and this pattern will grow like that. If it was odd, then what happens? If it is odd, so if we consider 0 as odd, okay, initial position as odd, I'm not considering 0 as odd. I'm just saying that just remove these numbers, okay? Just consider, because these numbers don't matter at all. We just need whether the current position is even or odd, okay? So just uh, don't mind these numbers. Just look at the color, okay? So if it was odd, that is green, then he'll move towards the right. Okay. Okay. I have started from 1 here. Okay. You can consider the number. Sorry. You can consider the number. Let us consider he starts from an odd position, which is 1. Okay. In here. So 1 is odd, right? So he'll move towards right by a distance of 1 as it is his first jump. Then again, when we simulate it, we can find the pattern. Okay, see, this is a pattern. What this pattern says that it moves to right, then left, then right. Is an absolute mirror image if you can notice that here it was left, right, right, left. This is right, left, left, right. But the distances are the same. That first jump will be of 1 unit, second of 2 units, third will of 3 units. Here also the first jump is of 1 unit, second jump is of 2 units. Just the sequence is different. That means it is a mirror image. Okay. So this is a mirror image that if it starts from even position and if it starts from an odd position. Now, if let's say this was he was not starting from zero, but let's say any other point. First, this pattern will also be applicable where it is even. Okay, so the starting position is even. So if here instead of zero it was 4, it wouldn't have matter because if it was 4 even position, so he'll move towards left by one jump because it is his first jump. So here, then again it will continue. So if where he starts from doesn't matter unless and until we just know whether it is even or odd. So the answer is that for even jumps, this is the pattern. Okay, this is the pattern. This is the distance we can say because we are what are we finding that this is these absolute distance. Okay, from zero. In case of 4, it will be shifted by 4. Everything will be shifted. If we shift everything here by so that 4 comes here, then it doesn't matter. Okay, the pattern is same. Just everything is shifted by 4. So what we can do is if x naught was 4, so we'll just do the answer what we the number of jumps we the final position or the final distance from the initial position does not depend on the initial position. It just depends on the number of jumps. But the final answer depends on the distance. Let me tell you clearly what I'm saying. Okay, so the final answer depends on the number of jumps plus initial position. The number of jumps because the number of jumps decides how far it is from in absolute distance from initial point. So n decides the absolute distance from the initial point, and this initial point, after including that in integrating that in the answer, we'll get the final answer. Like how in physics problems we used to do the moment of inertia about center of inertia, and then the moment of inertia of that center. Similarly, here we'll do the distance from zero, absolute distance, and then the initial position. So here we can say that if the initial position was even, then these are the final answers, and we'll just add. So the final answer will be just this k, okay? K, which is the absolute distance, okay? Absolute distance plus x naught. Initial position and initial position from 0, and this is with respect to 0. If this is valid if and only if the number of jumps is sorry, the initial position is even, x naught is even, because this pattern for which we have derived the k is for even x naughts only. This is for the even initial position. Similarly for odd position, as this is the mirror image, that means it will be negative, if you get what I say. Okay, like for here the distance is also k. Let's say k, if k mod k equals to number of jumps mod 4, and the pattern here is also fairly simple, that if it was just remove the numbers, it will be the same like k plus 1 sorry, n plus 1 minus n, 0 and 1. Just like how it was here, these all values. Similarly, these values will also be there. But just in this case, as this is the mirror image, you can see the mirror image, right? That left, right, right, left has been converted to right, left, left, right, where the distance remains same. That first jump is 1, the second jump is of 2 units. Similarly, here first jump is 1 unit, then second jump is 2 units. So it is just a mirror image, which means that distance will be negative. Here we have added the distance plus k. Here it will be minus k. So here the final position will be initial position plus absolute distance, which will be negative because it is an mirror image of this case. Okay, so what we have done in the code, let's see. We have found the absolute distance based on the number of jumps. As the number of jumps node 4 changes, the answer changes. And finally, if it is even, the initial position is even, so we will add the absolute distance to the initial position. And if it is odd, that is the pattern changes, then to the initial position we'll subtract the distance. Okay, so I hope you have got it. The observation was the main thing in this, right? Okay, thank you.